Here is an application of factoring. Show that 1 more than sum of the squares of 3 consecutive numbers is multiple of 3. I'd like you to copy the question, pause the video, solve and then look into my suggestion. Now let us write the equation for the given statement. The statement is, show that 1 more than sum of squares of 3 consecutive numbers is multiple of 3. Now what are consecutive numbers? Well, if one number is n, then n plus 1 will be the next number and n plus 2 will be the next number. So these three numbers will be consecutive numbers. Now what we need to show is that 1 more than, so plus 1 means 1 more than all this, in fact not just all this, sum of squares of 3 consecutive numbers. That means sum of squares, right? So we'll add the squares of these numbers. So that is the expression which we get from the given statement, which is show that 1 more than, so that is 1 more than plus 1, sum of squares of 3 consecutive numbers, so these are the 3 consecutive numbers and we add their sums, is a multiple of 3. So we need to show that this expression is a multiple of 3. This is what the question is. I hope that point is absolutely clear. Now we need to think how to show that this sum is a multiple of 3. Well, one thing is that if I try to factor the sum of these things, I should get 3 as a common factor. If I get 3 as a common factor, that means this expression is a multiple of 3. So that's the strategy. So let us see. So let's first expand and see what we get. So we get n square from the first term. N plus 1 whole square is n square plus 2n plus 1, and n plus 2 whole square is n square plus 2 times ab, which is 4n, plus 2 square, which is 4, plus 1. So this is what we get. I hope you remember the a plus b whole square formula, right? So which we have applied here. So let me write down this formula here, which is a plus b whole square, which basically means you're multiplying a plus b with itself, right? When you do that, what you really get is a square plus 2ab plus b square, correct? So if I look at this, n plus 2 whole square is n square plus 2 times these two terms, 4n plus 2 square is 4 plus 1. So like that. We expand it and then now we can combine the like terms. So if we combine these like terms, we get how many n squares? 1, 2, 3. So we get 3n squares. And how many n's? 2n plus 4n gives us 6n. And constants are 1 plus 4, 5 plus 1, 6 plus 6. And now clearly 3 is a common factor here. So we can say 3 times n square plus 2n, 2n plus 2, right? So dividing them by 3, we get this. So clearly we see that this expression is a multiple of 3, right? So that is how we can show that the expression is a multiple of 3, correct? So that is how we can do this question. I hope the process is absolutely clear. I'm Anil Kumar. You can subscribe to my videos and solve some more interesting questions. Thank you and all the best.